Hello, my name is Muhammad Alif Wijhdani. My student ID is 131182236, and today I will be presenting my experiment, my third mode experiment for the course MS3200 Basic Mechanical Phenomenon Practicum, and the title of my experiment is Conduction Set Factor Analysis Experiment. So, what is the phenomenon that became the reason for this experiment and analysis? What will we be looking at? As we all know, conduction is one mode of heat transfer, with the other being convection and radiation. It can be categorized as one-dimensional or multidimensional, steady or transient, and with or without heat generation in the medium. The type that will be analyzed in this experiment is the two-dimensional steady-state conduction. This type of conduction is hard to analyze analytically as it is time-consuming and in many cases, it's just not possible. However, using the step factors that have been derived analytically and tabulated, the schematics from the table could be recreated in order for us to be able to find the heat transfer rate. Here are the three cases that will be recreated in this experiment. As it can be seen from the table, there is a schematic, the step factor formula and also its restriction, and at the bottom of the screen there is the heat transfer rate formula with delta T being T1 minus T2, which is the temperature of the specimen, minus the temperature of the medium. Now, the apparatus for the experiment. The apparatus for the experiment is shown in the picture. There is a styrofoam box, soil and sand mixture as the medium, the sphere and cylinder specimen that comes in two different sizes, and the digital infrared thermometer which will be used to take the temperature measurement. And the apparatus will be shown better in the following video. Okay, so this is the apparatus, this is the box and the soil and sand which will be used as the medium, and this is the specimen, the cylinder. It comes in two different sizes for the experiment, and also the sphere which also comes in two different sizes, and this is the stove that is used to heat up the specimen into a certain degree, and this is the thermometer gun that is used to detect the temperature of the specimen and the soil. Methodology of the experiment. We will try to recreate these three cases of step factor system. We will then measure the temperature of the medium, and then we will process the data using the equation shown at the bottom of the screen. The methodology of this experiment will be explained better in the following video. For the first case, we will heat up the sphere until a certain temperature, and after the sphere is heated up, we will take the sphere. Of course, later on I will use a more safe equipment, not use my hand, and I will put the sphere in the medium, and then I will cover the sphere until it's buried inside the medium, and then I will detect the temperature of the soil. For the second case, it's similar to the first case, except now we will use the cylinder. So the cylinder will be heated up the same as before, and it will be put inside the medium, it will be buried, and then after it is buried, the temperature of the soil will be taken. And for the last case, for the third case, we will also use a cylinder. After the cylinder is heated up, the cylinder will be buried, but in a different position from the case before. It will be buried like this. It will be in vertical position until it's surrounded. Of course, later on I will not use my hand, I will use a safety equipment. And after it is buried, we will keep track of the temperature. And that is how the experiment will be carried out. The experiment video that will be shown in the following video will be fast forwarded in order to save time for the analysis. First, we will look at the specimen data, which the data is taken before we done the experiment. From the table here, we can see that each shapes, the sphere and cylinder, have two different sizes, and it also comes in different material, with the sphere being stainless steel and the cylinder is a plain carbon steel. Notice that there is Z for case 1 and case 2. The Z value is selected so that it will fulfill the restriction according to the shape factor table shown earlier. Using the shape factor formula from the table, the following shape factor value for each cases is obtained, and we should notice how all the larger specimen has a larger value. So sphere 2 is larger than sphere 1, the shape factor. The shape factor for cylinder 2 is also larger than the shape factor for cylinder 1. This phenomenon happen in all cases. Now we will see the temperature distribution for the first case. We should notice that the first sphere has a higher temperature distribution. It reaches a higher temperature. Why is that? Other than the reason that the initial temperature of the medium for the first sphere is higher, and also the first sphere is heated to a higher temperature. Other reasons that may be possible are because the second sphere is larger, it has a larger Z value, as shown in the previous slide. Therefore, the second sphere is buried much deeper into the medium, and because the measurement is taken near the surface, the temperature near the surface will be higher for the first sphere. There is a point where it going up and down in the first sphere and also the second sphere. This error could be because error in taking the measurement. Now for the temperature distribution for the second case. The difference between case 1 and case 2 is that for the second case, the cylinder is buried at a similar depth. So, because the second cylinder has a larger dimension, it reaches a higher temperature than the first cylinder as it has a larger dimension. We should also notice that for the first 30 seconds, the temperature of the second medium that has the second cylinder is actually going down. This error could be because the measurement taken is at a different point. The third case temperature distribution is similar in a way to the second case temperature distribution, as we can see that the larger specimen heat up the medium more. There is considerable difference in the peak temperature with case 2 as in case 3. The specimen, the cylinder, it is not buried completely, and it's closer to the surface where the measurement is taken. Other than it heat up fast, it also cools down fast. It also cools down fast, as seen in the peak in the graph for the second cylinder in the 20-second, 30-second, 40-second time interval. Now we will see the heat transfer rate value that has been calculated for the first case, the second case, and the third case for all the specimen. With the larger step factor, all the larger dimension has a larger heat transfer rate. This happens for all cases. And case 1 has a considerably larger heat transfer rate value because it also has a larger step factor value. And although case 2 and case 3 uses the same cylinder, the shape factor formula is different as the arrangement of the system is different. Therefore, it gives different heat transfer rate value results. The third case heat transfer rate value could also be lower, as in the third case, the cylinder is exposed to the surrounding air. The area of improvement for this experiment are the temperature measurement process. I think it's better to have the measuring instrument planted in the medium and it would be better if it is planted in multiple positions so we could analyze better the phenomenon. And although it is expensive, it may have been better to get a more accurate and precise measuring instrument. This experiment will also be easier done in a group as there is a lot to do during the experiment, such as preparing the medium, heating the specimen, moving the specimen into the medium, starting the stopwatch, and then measuring the temperature while also recording the experiment. So that is it for my presentation for the experiment. I hope this video will be useful, and I'm sorry if there's any mistakes in the content or in the way I'm presenting. I hope we can all stay healthy. Thank you and have a good day.